Ladies and gentlemen, esteemed guests, and data science enthusiasts from around the globe, welcome to the grand finale of the Data Science Conference MENA 2024. It's an honor to be standing before you today as we embark on this extraordinary journey into the heart of data science and artificial intelligence. I am Reem Tamer, your host for today. I'm a TV presenter for 16 years, and I'm really delighted to be with you today. Today marks a historic moment as we gather here at the prestigious Egypt University of Informatics in the beautiful city of Cairo, Egypt. For the first time ever, the Data Science Conference MENA is gracing the Middle East with its presence, bringing together over 500 speakers and professionals in the field of data science and AI from Europe, MENA, and beyond. This event is not just a convergence of minds. It's a testament to the power of collaboration. I am thrilled to announce that the Data Science Conference MENA 2024 is a strategic alliance between Intervento, Data Universe, ITIDA, and Egypt University of Informatics under the esteemed patronage of the Ministry of Communications and Information Technology. Let's kickstart this moment occasion with our keynote speaker, a distinguished figure in the realm of data science and a renowned academic. We are privileged to welcome a distinguished figure in the realm of data science who came all the way from Canada to Egypt to enlighten us with his knowledge in the opening keynote under the title of Data as the New Commodity, AI, Sustainability, and Financial Innovation. Please welcome to the stage the professor at the Department of Mathematics, University of Toronto, Dr. Luis Seco.
Cairo is the world capital for data science today. And I want to give a presentation which is going to present a historical perspective on the field to see what conclusions we can get from it. My focus is going to be sustainability. It is the problem of today, and data science will be the solution of tomorrow. In doing this, I want to recognize that we are in a historical place. History developed here. And when it comes to data science, I want to adopt a historical perspective on what's happening. I'm trying to make the clicker work. It is interesting that in the 21st century, with all of the artificial intelligence that we have around us and the data science, still the bottleneck of making a clicker work is one of the main challenges for humanity, okay? So it's happening now. Okay. So I want to start with a reflection when the presentation wants to evolve about how innovation evolves. When you look at the 20th century, it should be on the left. If you look at the 20th century innovation has been characterized by what I think are three characteristics. First, very small data sets. You can argue that the big accomplishment of the 20th century was to send the man to the moon. If you look at that, the amount of data that was used for that was very, very small. What we had instead was a situation with lots of equations. It's now moving 3 slides forward, so this is not working. And everything happened in physical space. So this was the summary of the 20th century. The 21st century is very different. The 21st century, we have lots of data. we have no equations, and everything happens in mental space. This is the sea change that we see in innovation happening in the 21st century. But I want to reflect on this by going 2,000 years back to Ptolemy, which I don't know how you pronounce in Arabic, but I wrote it here. It's supposed to be there. So I want to tell you about Ptolemy. I don't know how you say this in Arabic. How do you say this in Arabic? There you go. Okay. It's a very interesting element for us today because not only he was from right around the corner, but because of the way he changed things. Before him was Aristotle. Aristotle was focused on theories. You could say that Aristotle was about equations. There were no equations back then. Ptolemy couldn't care less for that. He just wanted data to tell him what to do. He was data-driven, not theory-driven. That was the big change that he did with respect to Aristotle, for example. Okay, then we had to wait until Newton. Newton is the one that then changed everything. He disposed of data altogether, and then he invented the big equations. And then everything has been evolving Newton-like until now. So we are now back in the times of Ptolemy or Ptolemaeus. We're back into that, where data is going to tell us everything that we need to know. And moving forward, we're going to have to recognize that we live in a world where there are just no equations. And what can we do with that? Well, the problems that matter today are these. We're no longer concerned about the movement of the planets. This is not something which is in anybody's agenda. What concerns us is the one planet in which we live in, and that is the Earth. What you have here are the 17 Sustainable Development Goals of the United Nations. 193 countries have said that this is what matters. It's no longer the movement of the sun and the earth. This is what matters. It's all about the earth. So what I want to discuss today is, what does data science have to do with this particular objective? This is what matters. So how do we deal with this? I have a very, it is a newspaper clip from the New York Times from May 24th, 1990, which for me is, in a certain sense, the beginning of a different way of thinking. Harvard University Endowment decided to divest from their tobacco stocks because they thought it was unethical. And what happened then was, thank you. What happened then was everything started to change, because suddenly you start to make financial decisions based on not what's good for your money, but based on what's good for the people. And that was, as you can see, in 1990. That was a long time ago, but this started a new way of thinking, a new way of acting. And if I look at the last 100 years of financial innovation, I could say that perhaps in the year 1930, about 100 years ago, that is when accounting started. This is the beginning of data science consumption for the financial industry. It's the first time that you could predict anything based on information that was reliable, that was accounting information. Over to 1950, that's when portfolio theory was invented, which coincides with the discovery of the computer. And then in the year 2000, when everybody had a computer on their desktop, is when computer methods developed, and they changed the financial industry. And now we are in the situation where what is changing is the data consumption. The data consumption is no longer the same data that we've been consuming for the last 100 years. The data that we consume when we make financial decisions is based on textual data, not numerical data. And this is one of the big changes that is happening in the financial sector today. We are replacing what was traditional data sets that consisted of numbers for data sets that now contain other things. When one talks about data and databases, we're no longer dealing with numbers. We're dealing with textual data. We're dealing with words. And very soon, we're going to be dealing with sensor-driven data, video, images. All of that is what we consider to be data. For this presentation today, I want to focus on the power of words. I want to talk about the relevance that textual databases, word as input, has in our ability to understand the world and maybe make a difference. Sensor-driven data, videos, images, and all of that will come later. Now, what you have here is a display of something you can do. It's something that a company in Toronto, Sibley, is able to do by you give it a particular company, and then you give it a criteria under which you want to analyze a company. For example, back to the tobacco stocks of Harvard University, you can try to understand how is this company scoring under data security, or how are they scoring under gender diversity, whatever criteria in words you pick. This is not numerical data. You give it textual questions to textual contexts, and then it gives you numerical data back. So this is an example of the power of large language models and what they can do for you, and they can analyze all of this for you through time. Okay, that's just an example of things that we can do. All right, I have a game here that if the clicker allows me, I would like to play with you. And this is to tell you how challenging sustainability is going to be for us. So this is a game that I have here. I give you a choice. You can raise your hand if you prefer choice A or choice B. Choice A is I will give you $900 for sure for free. So choice B is I give you $1,000 with a 90% chance, and I give you nothing with a 10% chance. You can see the expected outcome is the same. But think about it, and who would go for choice A? Raise your hand if you would go with choice A. Okay. Raise your hand if you would go with choice B. Okay. This is very unusual. Normally, no, there's some hope here, okay? You will see when we go to game 2. So normally what we get is, I'm happy that you answered honestly. Normally what people do is they go for choice A 90% of the time, okay? When you are dealing with upside, you want the money for sure. You don't like to gamble, okay? Let me go to game 2. Here, the choice is you're going to lose money for sure, or there's a small chance that you don't lose money. So let me play the same game again. Raise your hand if you go with choice A. You're happy to lose $900 for sure. Raise your hand if you're happy with that. No, very few people. Raise your hand if you go with choice B, where you... Okay, so this is what you normally get. Most people like to gamble. When there is risk of downside, they like to gamble. There's lots of consequences for this. The first consequence is that if people disagree, then what you can do is, this is how financial markets exist, right? You can see that game 2 is the negative of game 1. So if people disagree, that's how financial transactions happen. Things that you value and other people don't, then that's how financial transactions happen. However, when you think of, for example, climate risk, okay? Climate risk is a game of what? Type 1 or type 2? It's a type 2 game. So that shows that people like to gamble. Say, well, maybe it's not true. Or maybe, I don't know, something, maybe I get safe because someone discovers something tomorrow, right? The option of gambling is favored by humans when you're exposed to danger. And humans, machines will do something different. okay? If you ask this question to a computer, not ChatGPT is too human-like, but if you ask this question to a computer will give you a different answer because it's going to look at it in a rational way. But the human brain is not rational. We generate scenarios in a different way, and that leads to decision making. And this is the reason why sustainability has to be approached from a data perspective. Cannot be approached from a human perspective, from a human psychology perspective. We already see that. Let me go back even before Ptolemy. I'm going to go back to Hammurabi. Hammurabi was the beginning of the insurance sector. In the Code of Hammurabi, there's lots of things, some good, some bad. It was a remarkable development, but that was the beginning of the insurance sector. And I'm going to fast forward to the Paris Agreement of 2015 and point to Article 2.1c of the Paris Accord. Because what Article 2.1c of the Paris Accord says is that it says that it's going to make finance flows consistent with a pathway towards low greenhouse emissions. What does that mean? This is a statement that says that the financial sector is going to be the one to make operative the search for climate stability. That's what it says. It basically says that there's going to be trillions and trillions of dollars going into greenhouse gas emission control. How can we do that? There's only one way to do that, and that is through data. Now, I have three examples that I had prepared to present to you today. The first one is something that relates to finance. Finance is something very challenging for anybody doing artificial intelligence because in finance, we don't have the luxury of doing experiments. Everything happens only once. When you look at the planets, well, the sun rises every day. When you look at medicine, you can run your control groups and test trials. When you look at any engineering, you can build things, throw them up into the air and see how they land. With finance, everything happens once, so it's very challenging from an artificial intelligence perspective. I've spent a good chunk of my lifetime on that. And I am aware of the challenges that finance poses when you look at this from a artificial intelligence perspective. So we have some results that I'm just going to mention to you. I'm not going to explain that deep neural networks allow you to create new distances that allow you to understand how things will develop. And this is important when we apply this to climate change because this is all about relationships. We need to understand how relationships work and we can make decisions based on relationships. But I'm going to park this example. I'm not interested in this for the main talk today. I want to go to emissions. I want to go greenhouse emissions. The results are good, but you're not interested. I'm not interested today. I want to go to emissions. Okay, my interest is that the clicker works. There we go, emissions. Okay, so what's with emissions? What can we do with emissions? How is data science helping us with emissions? So data is helping us with emissions because emissions is a very simple problem. It's a very difficult solution, but it's a very simple problem because from a risk perspective, it's a single risk factor. Compare this to COVID-19. COVID-19 was a very difficult problem because we had no idea what was causing it. We had no idea what has impact on it. And that's why a good chunk of the world shut down until we learned what the risk was. With emissions, we know what it is. It's CO2 primarily, okay? And then when you do this is what people do. Again, this is the equivalent of the trading game. This is the wrong analysis. What people do is they list the emitting countries here. And I have, of course, if you do a list of countries' emissions by a number of inhabitants, by emissions, by their total emissions, you can see that China is number one. Right? And there's a lot of rhetoric basically saying China needs to reduce emissions. But then if you talk to China, China is saying, well, this is the wrong calculation. You should divide, because China has a very big country. So you should divide the emissions by the population, and you should do a per capita calculation. And if you do that, turns out actually Canada comes up as number 7. Why? Because Canada is mostly an empty country. So you know So data analysis is far more difficult to do than this. This is the wrong way. Either of these two tables does not give you any real information. They are just numbers, but it's no information. And you have to distinguish between data and information. So one of the things that we have done is you need to do proper emission benchmarking, for example. Okay? And this is a paper that I've done with some of my collaborators. And emissions depends on certain factors. And these are some of these factors you cannot change. You cannot change, for example, your population, right? You cannot say, well, let me cut down the population of this country by a half so I can reduce emissions. That's not in the works. We're not interested in that, right? We're also not interested in changing the electricity production of the urban population. And we cannot change the surface area. Let's just, let's just give half of the country to the United States, and then suddenly my emission number is good. It's just silly. You cannot do that. So what is the right benchmark to do that? And the right benchmark to do that is, well, let me see what my emissions are a function of, including GDP and other things, and let me see how well I'm doing with respect to that. Let me not focus on a single factor, which it makes no sense. And when you do that, something very interesting happens, which is now you have different countries, and you have what would be a real carbon footprint of those countries relative to the parameters that they cannot change. And there you can see that some countries are doing worse and some countries are doing better with respect to that. I'm not going to tell you which these countries are. I don't want to offend anybody. This is not about countries. This is about data analysis, okay? So this is the right way of doing benchmarking. But, and this is what I call emission chromodynamics, because it allows you to see if the country is going to become greener or browner over time. And this is what we really want to do. So data science will allow us to do that. And then I want to end my presentation talking about the next thing, which is what's really challenging, and a lot of the data scientists are working on right now, and that's to understand causal relationships. Because everything I've talked about so far is great, but has one deficiency, which is that it's all looking for things happening simultaneously. We don't know what's causing what. And in order to do that, you need to develop causal relationships. And causal AI is the big challenge that we have in front of us now. And this is something which is done through directed acyclic graphs, DAGs. This is the one, this is the context, the mathematical context in which we can understand how things imply things. We applied this in the context of, again, finance, because as I told you, finance is the real challenging area for us, because we have no way of doing experiments more than once. We can only run experiment once, so this is where you can really test your ability at guessing what's going to happen in the future. And this is the area where, again, textual data becomes very relevant, and the ability to use large language models for that. And what we managed to do is to get steps for causal directed graphs through the use of large language models. So I have here the steps that we follow for that. I guess you know ChatGPT. Large language models are very good, so we can do causal inference and understand through textual databases what causes what. And if we can do this well, we did this for credit, but finance again. But if we can do this for sustainability, we can do this for climate change, for example, then we will have an enhanced way of understanding what causes what. And if we do that, then data science will be at the beginning of our ability to deal with the climate emergency, and which again is an emergency from the perspective of a game type 2, where something bad could happen and then we need to take action, okay? And all of this is understood through the cluster relationships of the variables that actually matter. And let's see if I can get to the end of this, right? I think I give up. This is how we manage to get the relationships of the different factors, how they all apply with each other. And like I said, if we manage to do this well, then we have some hope that we can attack the problems of climate change, for example, or sustainability, where there's world hunger, or the efficient use of water resources in an optimal way. And that's the end of my presentation. There you go. Okay, thank you very much. I'm told that we can open the door for questions.
My question was about, I only attended the second half of the presentation, but when you were talking about causality and how to find the causality between factors, isn't this some kind of econometrics, like when you use Stata or eViews or some of these programs, it helps to do something like that?
No. Very good question. Very good question. If you look at econometrics, econometrics is all about things happening simultaneously. You don't know what causes what. In fact, we are led to believe that when you rate, for example, a linear regression, the fundamental tool of econometrics, then you have to decide what is the dependent variable and what is the independent variable. Mm-hmm. Okay? It's your decision. No one is helping you make that decision. Yeah. Once you decide that, then sure, I can do the calculations. Mm-hmm. But then you have to think, why do you think that's the dependent variable and that's the independent variable? I'll give you a very good example. Look at data, look at analysis, and see how many people die in hospitals. You would see that most people die in hospitals, right? So then you say, well, if that's the case, then if I'm sick, I'm not going to the hospital, because going to the hospital increases the risk that I die, mm-hmm. Right? Yes. Yeah, so that's how, if I can summarize econometrics would be arguing like that all the time.
All right.
And that's why we need to understand what causes what, and that's why you have to do things differently. And large language models are used for that.
Thank you.
Thank you. No more questions. Thank you very much for the one question we got there. Thank you.